Can you believe that the determinant of a matrix can be used in trading? Yes, believe me, you can use it. Now, back in March this year, I published a paper entitled Candlestick Geometry and Market Regimes, a Quantitative Approach. The key idea of this paper is to use the determinant of a matrix to help us in measuring the regimes of a particular security. And it works pretty well to any kind of markets. And the idea is extremely simple. Everything consists in understanding what a determinant really means. Remember from high school, we have a matrix in our example, just because it's a nice and beautiful square, we have a matrix 3003, a matrix 2 by 2, two lines, two columns. It consists of a vector 1, that is the blue vector over here, that we have 3 as the x-axis and 0 for the y-axis. And then another vector, the 0, 3, 0 for the x-axis and 3 for the y-axis, that is the green one. If we take the determinant of the matrix composed by these two vectors, we have the value of 9. That it's precisely the area of the square that we have projected in the 2D chart. Remembering from the school, in a 2 by 2 matrix, the determinant it's given by multiplying 3 times 3, or A times D, and subtracting B times C, or in our case, 0 times 0. So 3 by 3, of course, the result it's 9. That is exactly our area. What does it mean, right? If I would say or explain in a complex way, it would be like a matrix in this case, and its determinant would be how much of that transformation of the plane could be represented by this math over here. In a much simpler way, the determinant will give you how compressed, pay attention to that, how compressed or how, let's say, expanding we would be in a measurement given by such vectors. If we pick up that idea and translate it to the markets, what do we have? Leandro, I think we have the volatility. Yes, I can use the determinant of a matrix to understand when the volatility is compressing and when the volatility is expanding. And with that, I can therefore measure the regimes in any given security. One may say that, Leandro, there are already several dozens of ways of measuring market regimes. And of course, maybe the most famous one, it's the Markov chain, or the hidden Markov model in this case, which it's true and it's a fantastic tool. I'm not trying to convince you otherwise. I'm not saying that you should not use Markov chains or Markov models. What I'm saying is these models, they are awesome, but they have a problem. Whenever you have in your series of data a new data point coming in, all the past information you had or the regimes you have measured, they will be different at some point, depending on how that data came in. This is not good because if I would be doing a backtesting or if I would be offering a service to a client And I would like to have that photography from the past that eventually will change. And we cannot afford that. Therefore, we need a way to measure that regime continuously and in a way that new data points will not affect past calculations. There are some complex ways already to suggesting what to do in this case for the hidden Markov models, for example. But my point is simplicity works. And I cannot remember anything simpler in this case than calculating a determinant of a matrix. When we do it, and it's explained here in the paper, and it's free, and it's also free for you to use this indicator, you can build yourself as long as you mention the source and then you keep the name. The main idea is I can take the data that is available and it's very easy to get, that is the open, high, low, close. In this set of information, we have everything the market can give us. Current expectations, future expectations, past measurements of the market participants. With that information of the open, high, low, and close from the securities, I do some calculations that are explained here, but the main idea is I will come out with a matrix 4 by 4 that will be the covariance of that particular data points that we are having over here, like the opening and the moving average and all the rest that is explained. And from that, I will get the determinant. And the determinant in this case will be giving me that measurement of expansion or compression of the market volatility. And as you can see, for example, if I give the value of 1 for our V1 vector, that is the blue vector, the determinant will not change. It's yet 9. What has happened is you see the area of my parallelogram. We have no longer a perfect square, but I have now a parallelogram. It's yet the same as before. So the market has changed. Yes, it changed. However, the volatility, didn't. And here's the point. When the market eventually stretches, you see, or compress, that movement, it's what will tell us about its regime. And this, as you can see, is what we can capture with this particular information coming out of the matrix formed by the covariance of the data points that we have constructed from open, high, low, and close. I will leave the code or the HTML code of this very nice diagram over here into the research blog from om-qs.com. It's for free, right? You can open up there, download the HTML, and play around for you to get a better understanding about the determinant. But also, of course, I will leave you the PDF of the paper. And please, if you have any other type of questions, suggestions, you are more than welcome to leave a comment here in this video or join our Discord community. You will be welcome to discuss this as well because this is a working paper. I got some pretty nice results that I'm converting to attributes for my model. However, I think there are many other things that I could do in order to improve it, and I'm precisely working on that. And I will be expecting you as well to give me some contributions and ideas. Okay, my friends? So I hope you have enjoyed this class. Let me know any of your questions, subscribe to the channel, and see you next time. Bye bye.